Okay, we got cut off last time. This is continuing with section 3.1. This would be part 2. And when I left off, I was showing this example. You had 1/2 x greater than or equal to 4. And if I multiplied both sides by 2, 2 times the half just gives you an x, and 2 times 4 gives you 8. And since that's positive 2, it remains greater than or equal to. And then I was ready to shift over to this one. So on both sides here, if I multiplied by -2, negatives cross out and you end up with x. -2 times 4 is -8, but since you multiplied by a negative, that greater than or equal to now is less than or equal to. So the big thing here is when you multiply or divide by a negative, just remember to switch your signs. Okay. Next one we got here, this is in the book, says determine whether the points satisfy the inequality. So I'm just copying the equation, actually inequality, caught myself. So what we're going to do, we're going to take the 4 and plug it where the y is. I usually put parentheses around it. That means I plug that number in. And I'm going to put a question mark because we don't know if it's true. That's what we're trying to find out here. Determine whether it is true or not. And then the 3, I'm going to plug in here, so that becomes -2 thirds times, and in place of the x, I'm going to put 3 plus 4. So on the right side, that's just going to be 4. And over here, the 3's drop out. -2 plus 4 is 2. So the question is 4 greater than 2? The answer, of course, is yes. Okay, let's try 0, 0. So I'm going to do the same thing. Y greater than -2 thirds x plus 4. So I'm going to put 0 for y. That's what I get from right there. Greater than, and I'll put a question mark above it because we're not sure. And then for x, I'm going to put 0. So -2 thirds times 0 plus 4. Of course, that's going to be 0. Anything times 0 is 0. 0 plus 4 is 4. So you're asking yourself, is 0 greater than 4? The answer is no. So it does not satisfy the inequality. Okay, let's get into some graphing. So we're going to start with this inequality here, and really we're going to use the same rules we did for equations. Will be a slight difference. Okay, so you can easily look at that and say, okay, my slope is 2, so m is 2, and the intercept's -3. So that means on the y-axis, here's the y-axis going up and down, -3 is right here. And I know I got everything marked there. I'm just going to put -3 to emphasize that a little bit. And then a slope of 2, that's like 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. And then let's see how this works. If you got a marker like I've got, if you take your ruler and turn it upside down, that beveled side, I don't know if you can see it, will be up. If you don't do that, then sometimes it'll smear on you. So there's my line. Now here's where it's different for inequalities. You have to shade one side or the other. We're either going to shade the top part, what I say above the line, or we're going to shade below the line. I usually pick a point. In this case here, I would pick 0, 0. I think we can do this mentally. If I take 0, 0 and put it in here, for y, I'm going to have 0 greater than or equal to 2 times 0 minus 3. So is that true? That's what we just did on the other page. So you're going to get 0 on the left, and on the right, that's going to be 0 minus 3 is -3. Is that true? Yes. that means the point 0, 0 worked. It satisfies that inequality. And if this point satisfied, that means everything else on this side. And what I usually do, you can shade in the whole thing, but a lot of times what I'll do is just put hash marks, and you get the idea what it looks like. Before I go on, I'm going to say one more thing. I want you to notice the line. I drew a solid line, and I would do that as long as you have the equals there. I'll show you an example in a minute where you don't have the equals, and what we're going to do, you can call it dotted or dashed. Dash is a better term, but we usually just say dotted. Okay, so you drew that line exactly the same as if it was an equation, and then you shade one side or the other. Okay, here's another one, very similar. So up here, I got y less than negative x plus 4. I'll put it right here. So the slope is negative 1. The intercept is 4. So on the y-axis, remember the y-axis is always the one up here. So 1, 2, 3, here's 4. And a slope of negative 1, you can think of that as negative 1 over 1 if you wanted to, which means down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, as many times as you want. And once you get that, you're going to draw your line. You'll notice there's no equal here, so this is going to be a dotted line. Or a better term would be dash. We use those interchangeably. It's kind of hard to draw a dotted line, a pure dotted line. You make all kinds of dots and they don't look right. But now you can see my line and it is dashed. As you do yours, if you're doing homework and you want me to look at it, I don't care how big those dashes are. Just make it so it looks like it's either a solid line or a dashed line. No in-betweens. Okay, now, what side are we going to shade? We're either going to shade the upper part or the lower part. So we try 0, 0 again. So if I put 0 in for y, and the other side is going to be negative 0 plus 4. So is 0 less than 4? The answer is yes. 0, 0 is down here. That means we're going to shade in everything on this side of the line. If this was false, that means this point didn't work. I would shade in everything on the other side. It's one or the other. Okay. Okay, here's our equation. Y greater than x. So you can look at that and you can say, well, your slope is 1. That's 1x plus what? 0. B is equal to 0. And a slope of 1 means up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So you get the idea. Our line's going to be along those dots. Solid or dotted? There's no line, so it's going to be dotted, dashed, however you want to say it. Now above or below? Well, the previous two examples, I plugged in 0, 0. 0, 0 is not a good point to plug on this one because 0, 0 is actually on the line. So we need to pick something else out. And I usually either go with this one or this one. Let's put 1, 0 in and see what happens. So if I plug that in, okay, so it's y greater than x. So I'm putting in the point 1, 0. So that means 0 for y. And I'm asking, is that greater than 1? Because I substitute those two numbers in there. The answer is no. My point 1, 0, which is located right here, did not work. That's below the line. That means none of these points down here work. Everything up here does. So as you go through, I just use hash marks. Perhaps you like to actually shade it all in. Make it nice and solid. That's fine. I don't have a problem with that. Make sure you don't cross over the line. It's like when you were younger and you did coloring books and you had to stay inside the lines. Kind of the same thing here. Okay. Next example. This is a special one. M greater than 3. Okay. So you could think of that as 0x plus 3. If you wanted to, your slope is 0, your intercept is 3. I would rather for you to think of that as just, what if it was y equals 3? That's a special line. It's going to go straight across. It's going to go through at 3. And with a slope of 0, it's going to go straight across like this. I had greater than, so again, it's going to be a dotted line. And with it being greater, it'd be everything above the line. You could plug a point in to check that if you wanted to. For most situations, if it's greater than, it's going to be above the line, and if it's less than, it'll be below the line. If you're in doubt, plug a point in. 0, 0 would have been a great point to put in on this one. Example 5. At least that's why I got this one numbered. I know we've had more examples than that. Again, we want to graph it. Now, when you look at this one, don't worry about slope and intercept. Look at the x and y intercepts. So the x-intercept on this one, remember if you cover up the y's, so you got 2x and 6. So the x-intercept is 3. The y-intercept, 3y equals 6, so that's going to be 2. X equals 3. Y equals 2. We're going to draw our line. It's going to be solid because I got that line on the bottom. If you put 0, 0 in here, 2 times 0 plus 3 times 0, that's 0 plus 0 is 0. Is 0 greater than or equal to 6? No. 0, 0 did not work. So my answer goes off in this direction. And again, most of the time, if you got greater than, that's going to be above. I shouldn't tell you that because it's not always true, but most of the time it is. Okay. Now they get a little tougher. Here I've got two inequalities. I'll streamline this a little bit. On this one, my x-intercept, since it's standard form, I'll do the x-intercept. The x-intercept is 3, and the y-intercept is 4. So we got x is 3, y is 4. Got the equal, so I'm going to make this a solid line. And I'm going to put this down below L1. That way I know that was the first equation over there. Don't have to, it's just something I do. Okay, and then we got a shade. So let's just do it mentally. Does 0, 0 work? If I put 0 here and 0 here, 4 times 0 is 0, 3 times 0 is 0, 0 plus 0 is 0, is 0 greater than or equal to 12? And the answer is no. Okay, I'm going to switch pens because I'm going to do something here. I hope that you can still see this. I don't want this as dark, but my hash marks, or the point I would shade, goes out this way. But we still have another line to get. So now we got x minus y is greater than or equal to 0. Let's go off to the side here. X minus y greater than or equal to 0. If I subtracted x from both sides, I'm going to have negative y is greater than or equal to negative x, and I'll keep the plus 0 in there. If I multiply through by a negative 1, I got y. Over here I'm going to have x, and it's still going to be 0. But this sign switched because I multiplied through by a negative. So this tells me the slope is 1, and the intercept is 0. Here's 0. And a slope of 1, that's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So that would be L2. Okay, we'll switch pens here when I shade. But which side will it be? Okay, if I put 1 in here, 1 and 0, and 1 minus 0 is 1 greater than. I took this point and plugged it in. I found out that it worked. That means I'm going to shade everything on this side of the line. Hope that shows up. I tried making one blue and the other one red. Now I've done all of this, and now we're ready to put our answer. Our answer is the crosshatch area. So I've got hash marks going here, I've got hash marks going here, and they're going to intersect out in here. See where the hash marks, they cross each other? That's called the crosshatch area. My answer will be all the points in that area. So neatness is starting to kick in here. So now, since it's the intersection of those, I want to shade everything out that direction. I don't know if that's going to be dark enough. Barely. See if I can make it just a little darker. Yeah, that's a little bit better. And then one last thing that I do on mine, not so important on this answer, but this here is an edge. When I have an edge, I like to darken it. I want to make it stick out. Same thing going this direction. There's an edge down here. Now your answer sticks out and you can see exactly what it is. Your answer would be all of these points in this region. And that goes on infinitely. We would call that an unbounded region. A bounded region means you'd have all the sides in there. You know, perhaps you'd have another side here forming a triangle and it'd be all these points here. That would be a bounded region. More on that as we go along. Okay, so the problems are starting to get a little bit tougher. Okay, let's go to this one. I got this one labeled example 7. Okay, so there's my first equation. I'm going to look at that and I'm going to say the x-intercept is 8 and the y-intercept is 4. Let's go ahead and do the other one here. So the x-intercept on this one is 3 and the y-intercept is 6. Now on my graph, because I basically Googled it and just copied in on my work here, it goes 0, 1, 2, 3, and so on. You're going to find many times you can't do that. For example, here x is 8. 8 is over here someplace. Now you can kind of guess if you want to, but my suggestion would be let's let each one of these be 2 units. So you get 0 here, 2, 4, 6, 8, 10. So x is 8 would be right in here. And then if you did the same thing up here, now you can have this go every 2 and keep this one every 1. You know, they don't have to necessarily be the same. But I'm going to do that. So there's 2, 4, 6, 8, 10. As long as you label your axes and everybody knows what it is, then you're okay. Okay, so going back to this one, x was 8, y was 4, so that's right here. I'm going to streamline this a little bit. It's a solid line. Okay, and then we're going to shade in. I put 0, 0 in, it works. That's all of these down in here. Now that's one line, we still need to get the other one. So on the other one, let's see, x is 3, so here's 2, there's 4, 3 is going to be right there. And 6, the way I redrew that is right here. So my line, that was L1, this is L2. And if I put 0, 0 in, 0, 0 does not work, so this is where you guys have all the artistic abilities can kick in. So here's the line I just did. 0, 0 did not work, so none of these down here do. All of these up here will work. By making those different colors, when you're all done, you can pick out your work a little bit better. That'll help when somebody's looking for your answer, or if you wanted to go back and check anything. Okay, so this is the crosshatch area, so I'm going to shade everything in here. And remember that goes on forever, so that's an unbounded region. And then I would darken the edges on this. It's kind of like geometry. We still call these edges, and you know, you got a vertex there where the two boundaries come together. And that shows up pretty good. And your answer would be everything right in here. Okay, I think I got 2 more examples. We'll try to get through this. They get a little tougher as we go along. Okay, so now you have 4 inequalities. Check them out. X greater than or equal to 0, y greater than or equal to 0. So if x is greater than or equal to 0, that means I've got a boundary right here, and it's going to be everything to the right. That barely shows up, but I don't want it to be any darker than that. And y greater than or equal to 0 would be all of these. And I haven't even got to the main inequalities yet, but right now I know my answer is going to be up here. When you put these 2 here, you're really saying we're only going to work in the first quadrant. This is the first quadrant. Okay. So now let's go back to my main inequalities. I got x plus y minus 6 less than or equal to 0. all I'm going to do, I'm just going to put my x-intercepts and y-intercepts. We can do this in our head. If I want the x-intercept, I cover up the y, so I got x minus 6 less than or equal to 0, so x equals 6. If I did the same thing to find the y-intercept, I'm going to have y minus 6 equals 0, so y is equal to 6 also. Let's go to the second one here. If I want to find the x-intercept, I cover up the y's. I got 2x minus 8 equals 0. Just think as equals. So x would be 4. And the y-intercept would be y minus 8 equals 0. Y would be equal to 8. I usually get all the intercepts first because I'm going to use them to decide how I'm going to space off my my axes. The way it's spaced off now, it goes out to 6. I'm okay for the first equation, but the second one, I got an 8. I'm out of space. So on this one, I'm going to go 2, 4, 6, 8. Same thing going this way. So on the first inequality, it's 6 and 6. And at this point, almost always the line's going to be solid. Okay, and take my word for it, from this line, I'm going to shade this direction. Now you're going to notice my hash marks are a little bit smaller. I don't want those any bigger than they have to be, because you start getting too many lines on here, it becomes confusing. Hopefully you can see right now with the x greater than or equal to 0 and y greater than or equal to 0. That put us up here in the first quadrant. Then I put this line in. So out of that first quadrant, now I'm only talking about these points here, that little triangular region. But I still got another inequality. So this hits at 4 on the x-axis and 2, 4, 6, 8 on the y. So there's L2. And please take my word for it, but here's the line. It's going to be all of them coming this direction here. The more you put on, the harder it is to see where the answer is. But at this point, if you can see this little region right here, a minute ago I was talking about that triangular region. This is a four-sided region. We call that the polygonal region. Oh, this book calls it the feasibility region. I'm going to let you read about that one. Bear with me while I'm shading in. It's a lot better to do this on paper than just trying to do it on a, say, a chalkboard or dry erase board or something like that, whiteboard. Okay. So now you can see your answer is going to be this region right here. I call it the polygonal region or the feasible region. And what I want you to see here is, change my marker again, you have an edge down here on the bottom. And if it helps, make that a little darker. And you got an edge over here on the y-axis. And you got an edge down here. And you got an edge over here. So there's 4 edges. You've also got 4 vertices. We'll do something with those vertices a little bit later. Okay, I think I got one more. Get this done. Okay, so you'll notice you got x greater than 0 and Go ahead and make that greater than or equal to. It's supposed to have that. Y greater than or equal to. So we're talking about the first quadrant. I know I've got this grid here and I got an axis in there. If you will allow me, I'm going to reconfigure the graph. Call that the y-axis and this the x-axis. You might ask, why am I doing that? Well, partly my original, I just Googled that so I'd have a grid, but it doesn't really work for us. Remember, when you have these two here, that means we're only working with the first quadrant. So I don't have to worry about quadrant 2 or 3 or 4. I'm just looking at this upper right-hand quadrant. Plus, it's going to spread your units out a little bit, and that'll help you see your answer a little bit better. Many times, if you're not careful, I'm going to go back to the other one. If you're not careful with your units, and I was almost not careful enough here, this gets so small you can't tell what it really looks like. It looks really teeny. You want to try to spread things out the best you can. Okay, so this inequality says 2x plus y greater than or equal to 50. Okay, so I can look at that and say, okay, the x-intercept is 25 and the y-intercept is 50. On the second one, the x-intercept is 40 and the y-intercept is 20. Now, by knowing those, that's going to tell you how you're going to partition this off. So I've got 25, I got 40, I got 50, I got 20. 50 is the biggest. I think I've got 10 units here, so if you take 50 divided by 10, let's make each one worth 5. 5 on that one, 5 on that one. And you don't have to put all the numbers, just put enough where I can tell what it is. Okay, so back up here, x is 25, so 5, 10, 15, 20, 25. And the y value is 50, so 5, 10, 15, 20, 25, 30, 35, 40, 45. 50's up here. So I'm going to draw my line. It's going to look like that. Okay, which side are we going to shade? Below or above? If you put 0, 0 in, you're going to find out it does not work. So I'm going to put these, and I'm not going to put big long hash marks.